I have turned on recording, and as emphasized on KLMS, and I'm happy to repeat that here again. If you object against being recorded, then please contact me in advance. So for now, you're being recorded, and we will put that video on YouTube like the previous one as well. Thank you very much. Have you watched the previous videos? Okay, good. So that means I'm also gonna be able to cut short the introduction and motivation to today's session. Virtual reality is a popular topic focusing on applications and technology, but usually disregarding all the foundations and the background that particularly philosophers have investigated and explored about what reality is even, right? So talking about virtual reality without knowing what reality is kind of paradoxical. And today we'll listen about the second part of the philosophy of reality, maybe about the simulation hypothesis. I'd like to ask you, everybody, to keep your video cameras turned on. The schedule is 40 to 50 minutes presentation, roughly, okay? And then we're going to have some discussion. And also that, if time permits, we'll talk about the movies that you have watched as assignment towards this first part on virtual reality. So without further ado, I hand the microphone and the screen on and pin. Yes, now you have the spotlight.
Okay, thank you, Professor. Can you allow me to share my screen? Okay, thank you. Can you see my slide? Oh, okay, so let's begin. So I am Siripon Sutthiwanna, or you can call me Ted. Today, I'm going to present to you about the simulation hypothesis. Well, as the name says, it is the hypothesis that we may live inside a simulation. So let's begin on why should we discuss this on the first place. Okay, so the simulation hypothesis is like Björn has discussed about the reality. We try to also hypothesize the characteristic or the origin of reality, but this time we base it on what we can create, and to be more specific, the virtual reality we can create. And so why do people come up with this idea in the first place, right? So there are three things that could motivate people to think of this idea. The first one is the questioning of illusion of reality itself. So as kind of going to have discussed on Tuesday, we have discussed on the Zhuangzi dreams of butterfly and also Descartes' demon. Another motivation is the belief in the creator of reality. I'm sure that many people believe in this because it's quite hard for us to imagine infiniteness, or that everything just happened to emerge out of nowhere. That Big Bang just happened because it happens, or that intelligence just emerges from some amino acid that got struck by lightning, and then evolved over time to have ability to think and self-awareness. The things seem to be too perfect in many ways in nature for us to be arrived here. Thus, many believe that there have to be some kind of influent force, an intelligent one, that is behind all the fine-tuning of our universe. And those two are quite classical. Many philosophy and religion has already thought of this for a long time now. But what makes simulation hypothesis is also the simulation technology itself. People have advanced the simulation tech and video games in a surprisingly fast pace. It has to realize that Pong was released 40 years ago. There's some white pixels on background running at 50 frames per second. And last year, Epic Game has released tech demo for Geometry Reborn, showing a photorealistic scene with ray tracing and also facial expression, big city map, all can be rendered real time with just Xbox and PlayStation. This all happened in 40 years. So it's not far-fetched to imagine that one day human will be able to simulate the whole universe, or maybe simulate all of history of humanity, or to create virtual reality so realistic that we couldn't differentiate between which picture is from our reality or which one is from video games. And of course, then we would have the question, if we can find that virtual reality is so realistic, can our reality also be virtual on some plane of reality? And before we discuss on about simulation hypothesis, let's define it more precisely so we can discuss it more properly. So I have thought of two criteria that would make simulation hypothesis. The first one is that there has to be reality outside the simulation. Otherwise, it wouldn't be simulation if there is nothing outside the simulation. The whole simulation would be just reality itself. An example that I would like to give is, let's say Greek god were to live on Mount Olympus or the same earth as ours, then that wouldn't be a simulation because the creator of human or creator of the reality we live in also live in the same reality as us. Of course, this is just boiled down version of Greek mythology. I'm sorry if I got some part wrong. And another criteria would be that there has to be someone that simulates us. And by someone, I mean some intelligent being. Maybe they are human, maybe they are aliens, or maybe they are the omnipotent God. The reason I think this is important, because if there's no one that simulates us, then the action of simulate wouldn't exist. Thus, there's no simulation. An example that I give that is not simulation in this case is if we were to be inside a computer that, well, just exists. There is no architecture that designed it. There is no programmer that programmed the simulation. It just emerges out of nowhere into existence. In that case, the computer wouldn't be a simulation. It would act more like the border of universe or the box that contains our reality, because it simulates nothing and there's no one that runs the simulation. So that is not an example of this hypothesis. Okay. So now that we have established some motivation and what is not the simulation hypothesis, let's explore the arguments that we have on this hypothesis. The first argument that I would like to talk about is probably the most influential one in this theory. Professor Nick Bostrom has wrote a paper called "Are You Living in a Computer Simulation?" in the year 2003. This paper argues about the probability that we live inside a simulation. So the argument begins like this. In sometime in the future, humans will run a simulation of the entire history of humanity. Okay, the reason we may not know, but he theorized that maybe they want to simulate it to in order to learn about history of their ancestor, or maybe tweak something to see how human would behave, how the belief would change depending on some factors. He called this type of simulation ancestor simulation. But of course, in order to make that model, we also have to be clear on this one assumption first. It is that in order that for us to simulate human, or in order for future human to be able to simulate human-like artificial intelligence, we must make sure that our consciousness isn't specific to this body, that my consciousness can be replicated in computer and isn't based on the communication between neurotransmitter inside my brain. This assumption is called substrate independence. For now, we will assume that it is real, because I would not like to discuss this part as it is belong to the AI section of this course. So let's just assume it. Now that we have established, now that we have some hypothetical model of simulation, what will happen? Since in Nick Bostrom idea of simulation, human simulates human. And of course, they would want to simulate them as realistic as possible, right? Otherwise, it wouldn't be useful to study the history or study about the behavior of our ancestor. Then the simulated human would think the same as human, have the same knowledge, have the same motivation, and everything. That means after a while, inside the simulation, the simulated human will also run simulation. Why? Because the human that simulate them also run simulation. So they have to do the same. And you may see where this is going. The first simulated human will simulate more human, and the doubly simulated human will simulate more human. We can expect this simulation to be something like layers of reality, or in this case, layer of simulation. It could be infinite, it could be finite, maybe it doesn't even have origin at all. The main character of it is that it is layered. The arguments that he arrived from this model of simulation is that one of these 3 points should be true. The first one is that human will go extinct before the simulation can be invented, or alternatively, simulation cannot simply be invented, which is quite a sad outcome. Or the second proposition is that future human doesn't want to run the simulation, which in a sense is just an alternative for the first one. The first one is that we lack the ability to. The second one is we lack the motivation to. But the third simulation is that if the first and the second one is not true, then we are almost certainly inside a simulation. So how does Professor Nick Bostrom arrive at this conclusion? Let's go back to this expanded version of the diagram. His reasoning is simple. If the simulation can be multiple layers, and in each layer they can even be many instances of simulation, then it is really, really low chance that we would exist at the top level of reality. That is assuming we know that top level reality even exists, that it doesn't just happen at a simulation in the first place. And since this tree could have infinitely many layers, have infinitely many branches, thinking that we are the first reality is just a bit too optimistic. So that is how he arrived at the conclusion that we are almost certainly inside a simulation. But do note, however, this conclusion is often misinterpreted. In order for we to arrive that we are inside a simulation, we have to make sure that we are able to construct a simulation in the first place. Maybe not now, but in the future, in the far future, we can construct it. If simulation cannot be constructed in the first place, then we wouldn't arrive at the third conclusion. Okay, Many people have discussed this argument. I think I have to see two influential people that have discussed this one. One notable person is Elon Musk. However, he interpreted this conclusion as quite a bit depressing, in a depressing way. But I believe that this conclusion that doesn't hold true as an argument that just confirm. Rather, it discuss the probability. Okay. So what Nick Bostrom conclusion tell us about is the significance on why the significance of this theory, and also a way for us to imagine that reality can be connected to the thing we can construct, because his main argument is based on the hypothetical simulation that we can build in the future and use some kind of induction, maybe not strict, to induce the probability. And now let's just look at the other side of this hypothesis debate, which is the computability of counter argument. So when people talk about we being inside a simulation, the most often counter argument people bring up would be that our universe simply too hard to be simulated. So what does one need to compute the whole universe? From physics estimate, mass and energy can be converted into bits of information. And by that estimate, we can approximate that the observable universe contain around 600 million billion bits of information. And the entire universe could potentially even be infinite, and is also growing at almost speed of light. In order for us to construct the simulation of the whole universe, we would need a digital computer that potentially can contain infinite amount of memory. So does that mean it is impossible to simulate us? Well, there are two ways out of this. The first one is that then we should do some optimization before we simulate the whole universe. So what are some optimization that could be done? The first thing is that we don't need to simulate everything inside the universe. We only need to simulate the whole universe to a reasonable degree, to the accuracy that one would need to do their study, or they would need to play in video game. Maybe the computer only need to simulate what brains or what the NPC and players can see. Maybe they don't need to simulate this pen when it is out of view from the camera, or this pen, or the inside of this pen, or how the atoms inside of this pen bounce around and interact with each other, and only render in high level of detail when I look at it closely. These kind of optimization techniques already used in video game today. On the left figure is show what we call cowling, which is basically video game not rendering object that player can't see. Maybe it's outside of view, maybe it is behind other objects. And another figure is called level of detail, which basically means that we only use high level of detail for objects when players look at it closely, such as the first bunny. And when players are far away, we just use the low level detail of bunny instead. And this could save us a lot of memory. The maximum bandwidth of what human brain can receive is around 100 megabits per second. To put that in comparison, 4K 60 FPS video, which can be run on any computer, pretty much every computer now, is around 85 megabits per second. So even if we need to simulate, let's say, 100 billion humans, the amount of data we need to simulate is a lot less than what we need to simulate the whole universe by many, many, many degrees. And that is assuming we are even using digital computer to simulate the reality. Maybe we have people in the future have developed quantum computer that could solve wave function in an instant. Or maybe they have developed the entire new machine for simulation. Or maybe our physics just doesn't apply to their physics. Maybe they are, in a sense, omnipotent and infinitely powerful God, such that the infiniteness of the universe just a finite point in their reality. Thus, the counter-argument that our universe cannot simply be simulated is not quite doesn't quite reasonable in this case, because we don't need to simulate the whole universe, or maybe there is a way to simulate the whole universe that we don't know. Okay, so now that we have clear two things, so far we have talked about that we are possibly in the science simulation, and that trying to disprove it by basing on what we have constructed may not work. Let's talk about then how can we actually prove this hypothesis. And before we actually go into the experiment or things that people try to come up with in order to prove that we are inside a simulation, it is impossible to not mention glitch in the matrix. People often joke about this when they say something that duplicates or something that doesn't behave the way like in nature. And if someone were to say that they believe they are inside a simulation because they see glitch in matrix, no one is likely going to believe them. But of course, there is an argument that is leaning toward the possibility of the glitch in the matrix. If in some instance, the one that simulates us is human-like, doesn't need to be human. They can just have intelligence comparable to us. So like in Nick Bostrom model of simulation, that would be an example because human simulate human. Then they may not understand every rule of physics and every formulation in the universe. Thus, they cannot make perfect simulation. And also because they are human, they are probably make mistakes and bug when programming. These mistakes, of course, will create bugs or glitches. And when the people who run simulation notice those glitches, they will also likely to patch it because then the simulation would diverge over time if they don't do something about it. Over time, these changes to the code base would compile larger and larger. And so at some point, our reality would change so much to the point we can notice glitch in the matrix. But of course, there is also the question that if the glitch exists or that the reality has changed, would we be able to observe it? Well, so that is one question to think about. But what I would like to more focus is actually the thing that people have tried to do, that scientists and researchers have tried to prove or disprove the simulation hypothesis. So from the movie 13th Floor, after the protagonist has realized that in simulation there is border outside of the city, he go back to his reality and drove away from the city to see if his reality also have a border. And he found one. So in a similar manner, can we do the same as him? Can we find the limitation or the bug or some design choice in the simulation we made and try to find some rule of nature that is similar to those things that we have made? One thing that people usually bring up in this search for evidence to prove or disprove simulation hypothesis is discrete spacetime. So this theory is that space and time is actually not continuous. Space is actually grid-like in position, and time is not, and there's some resolution in time such that we cannot have an interval less than that smallest interval. This theory is possible according to physics and math, but it has yet to be proven or disproven by experiment, like many theories in physics. This is comparable to how we implement physics simulation or video game today. Position has some resolution or is grid-like because of how we store value inside memory. Load have resolution when we go too deep. And time has some limit in the smallest size of interval because we usually run the simulation in some kind of loop. And this loop, once this loop finishes, we advance time by one step or one tick. So some people try to connect these two things together, such that if we can prove that this grid and space-time really exist, then maybe we are inside a simulation. A proposed experiment to prove this existence of discrete space-time is to search for anisotropy in cosmic rays distribution. The word anisotropy means that it is not truly random. There's some kind of noticeable pattern when we observe it for some time or observe it over some area. If you can observe the pattern, especially grid-like pattern or pattern such that actually is discrete, or pattern such that the cosmic ray is actually not random over time, then maybe we can conclude that discrete space-time does exist. And why cosmic rays? Cosmic rays are rays that come from far out in the universe. It can come from as far as the observable universe. And since that distance would be not too far, very, very far, we would expect some kind of estimation from when trying to calculating those rays distribution or those rays trajectory. So that would be the basic case for us to find these discretize in space and time. But however, there is still one question remains. Even if we can do this experiment, we find and prove or disprove the hypothesis. Can we actually conclude that we are inside or not inside the simulation? Well, how can we be so sure that once we got the test result, the simulation wouldn't just edit it? Or the simulation is designed in such a way that we can understand the result that we are inside a simulation. This kind of question is similar to the debate of trying to prove the existence of God that has been debated for a long time now. Can we actually prove the existence of God? How can we be sure that God doesn't have a way to deceive our senses? Or how can we be so sure that we can understand God? How can we be so sure that we can understand the reasoning, the logic, the rule of nature of the programmer who made our simulation? So in a way, the only way we can know truly that we are inside a simulation is when the people who run the simulation tell us. Maybe they send a message, we pop up on the sky. Maybe they just implant memory onto our brain that make us aware that we are inside a simulation. In that case, it would be easy to prove it. However, to disprove it, that is a whole another story. Because then there is no authority figure. The figure in this case is the one who running the simulation that would tell us that we are not inside a simulation. And we cannot also assume that any physics, any knowledge, anything we know is actually true or is actually not constructed in a way that we can prove simulated reality is not true. Okay. So, yeah. What I have discussed so far is probably on the side of argument of the possibility of this hypothesis. So let's stop trying to arguing whether if it's true or not true and move on to some more philosophical thought experiment by assuming that we are indeed inside a simulation. There can be two things. There can be, sorry, there can be two ways we exist inside of simulation. The first way that is we are simulated. Another way that we are not simulated. Let's go over the first case first, that we are simulated. Or in terms of video game terms, that would be that we are AI or we are NPC, non-playable characters. How would we think of us as, how would we think of the existence of us? So that, okay. One way to think of our existence such that we are simulated is probably Descartes' approach. Descartes had said that he thinks, therefore he is. In a sense, we could also apply this into the simulation. We could think that because we can think, because we can feel the self-awareness, and because we can perceive what we exist, then in that case, the simulated reality or our reality is real for us. That is one way of thinking. Another way, if you are kind of materialist, of course, you say you are not so real, because then you are able to describe by some code that construct you. Another way, of course, is just say, so what, right? Because the simulated reality is what we perceive and we live in. This is what our identity belongs to. And I think this third case is actually the easier one of the two that is to reason with in about the existence of ourselves. But the more complicated one would be when we aren't simulated, where we are players. So inside the matrix, our real body is sleeping inside a pod, but our consciousness or our thought is playing some inside a simulation, and we are not aware of the existence of outside. But in this case, our brain, our body, our everything originate outside of virtual reality. This would the most comparable to what we have today when we wear a headset or where we play video game. In this case, what is the real us? I think it's, yeah. I think I arranged this slide wrong. I apologize. Okay. In the scene from the prison on the victim of the brain, Dennett has his brain separated from his body, but linked via radio transmitter. He questioned whether he is inside or outside the tank. Because he can perceive the world where his body is, then he is the body. But since his existence doesn't rely on the body, it relies solely on the brain, then he exists inside the brain. We can also compare this to this debate earlier. If we are inside the matrix, or that we play some video game and can dive to lower virtual reality, where would we be? Would be the thought that is thinking inside a simulation, that experience the life inside this reality, and that is have his knowledge, have his idea, have his motivation, all come from this reality. Or the body that is sitting outside the simulation, that if that doesn't exist in the first place, then we wouldn't exist. I believe that all of you are not a players, or such that you have no memory of being outside. If you have one, please tell me. So there can be two possibilities if we are players, such that but we are not aware of it, is that we may have never seen outside of reality, such as in the Matrix. Another case would be that fake memory has been planted and our memory has been altered in some way. Maybe it is in destructive way, such as when you wake up from the virtual reality, you cannot forget what inside the simulation, or it's merged with yourself in the upper level of reality, such that you can remember both the experience outside and the experience inside. Or maybe this fake memory is temporary, such that you forget everything when you wake up. And maybe you can only replay it via video recording of yourself playing this game. Then, if that such is the case, then what would be our identity? Would our identity be the same inside the simulation and outside the simulation if we have no memory of the outside simulation? Could going between reality separate our identities? Or are we still the same person, going both inside and outside, just role-playing, just acting as someone else? And that is why I moved this. And that is why I think the situation where we are the players can be more complicated than when we are simulated. That is because we have clear connection of what is materially real and also real by perception. Okay. So I know that the last part of this, I just dumped you a lot of questions that leave you left unanswered because I want you to think about it. Now let's go on to the conclusion, which is not a summary, but even more questions. Previously, we have used our insight from creating virtual reality to look above to see the hypothetical upper reality. So now let's go in reverse and use the insight that we gained from trying to think about the upper reality and look back down on the reality we have created. So let's assume that we are still real, even if we are simulated. I know that everyone may not agree on that statement, but for the sake of discussion, let's think that we are real and simulated. In that case, can the virtual reality we created also be real? Let's use this slide that I had made and readjust the logic and question a bit. Instead of having the reality above us, let's have our reality be top-level reality and also have lower reality exist below. If I play a virtual reality game and my thought is and my perception is inside the video game, would I be inside the game or would I be outside sitting on a gaming chair? And would I be the character that I am playing? Would I be the hero that is slaying dragon to save city? Or am I Siripon, who is just wearing a headset and role play as that person? So this question of reality is, I won't be answering this right now because we still have many lectures left to explore about in virtual reality. But that it would be the question that I would like you to think about. And for the conclusion part of actually simulation hypothesis, I would like to one last message about simulation hypothesis for people who are skeptic about the simulation. In the last scene of Inception, our protagonist is back at his reality. And in that reality, he lived happily with his family and his daughter that he has never seen her face. He didn't even bother looking at the spinning top on his table to check if this reality is real or not. So that's the word in reality. Does the word real in reality have any bearing? Is it important to know if we are inside a reality, a virtual reality, or in a simulated reality? If we can be happy? Should we even seek the question, answer to this question at all? So, and that would be it for my presentation of simulation hypothesis. Thank you. I'm sorry it is a bit short, shorter than 40 minutes.
No problem. You were
okay, thank you.
Spot on timing. But yeah, we'll discuss the quality of your talk later. Let's first discuss the content and possibly answer some questions. So, right, maybe we stop the screen sharing for now.
Okay.
Right. Yes. So how about questions? Somebody has questions? Yes.
In the inside this simulation, who are we section, there is two possibility. You said we are AI or we are player, but I think those both aspect is very human centric, because if I am a designer of this simulation, then I think I make like kind of physics simulation, because our world is very complicated and we can observe many physical interaction in our world. So I think if the programmer, I think there is no reason the programmer design the simulation in human-centric. So how the programmer in outside our simulation could, which one is human or which one is intelligence? And is it possible to the programmer could recognize us? Yeah.
So I see what is the question. So maybe, so the question is maybe our intelligence is simply not designed or accounted for, but actually emerges from random physics inside a simulation.
Yeah.
Correct?
Yeah. That's correct.
Okay. So first thing, I wouldn't think that. So about the who are we section, I wouldn't think the answer to who are we in that case would be so much different from that we are simulated, right? Because then I don't because in that case our existence wouldn't rely on the people who design the simulation, because we exist as a separate entity. But in the other hand, it would mean that our existence would be a bit meaningless, I would say, as it wasn't accounted for, if you care about the meaning of life or why we exist. That what answer?
Yeah, kind of.
Question?
So, okay. So my question is how they define the entity? Yeah. So
So yeah, but I can see the point of your argument. That is what I have been discussing about is probably very arts centric, right? From the perspective of us, rather than the perspective of the one who designed the simulation.
Mhm.
Yeah. Well, I cannot lie. I haven't thought about that perspective.
Mhm. Okay.
That is very interesting.
Thank you. Another question? So this is a very philosophical topic and subtopic, and that may be new or strange or alien to students who have joined KAIST in order to study engineering and technology. But that's precisely the purpose, to kind of make you move out of your intellectual comfort zone and to push you and to question things. So for example, also simulation hypothesis is kind of popular, right? So Nick Bostrom is kind of a pop star among the philosophers. And even Elon Musk does not dares to speak out and have an opinion about the simulation hypothesis. But again, few people really realize what the simulation hypothesis really is. And Ted has pointed out and raised many questions about what it actually means to be a simulation and what the simulation hypothesis is about. Gang Dok-hyun, you're a philosopher. You have given a very good talk about philosophy. So I was just wondering, maybe you have some comments or questions?
Not a question, but I do. A thing came to my mind when the presentator. Sorry, I cannot read your name very well. Is it Sutthiwanna?
It's Siripon. Or you can call me Ted.
Siripon. Okay, so when Siripon said something about the meaning of life and things, and probably this thing that I'm going to talk about is also related with this simulation hypothesis as well, just in a different perspective. So there is a guy called Friedrich Nietzsche, if you have heard about him, in, I don't remember correctly, but about 19th century German. He has a very mixed evaluation among philosophers because he is very exotic. I read his work a few times, and one of his most notable work, Thus Spoke Zarathustra, is more like a long poem than a philosophical book made by any other philosophers, such as Wittgenstein, Descartes, so on and so on. Anyhow, the story of Zarathustra goes on to like this. There was a very wise man called Zarathustra. He was meditating in the mountains, and then one day he thought that he should share his knowledge, the thing that he came up with the men's under the mountain. Basically, his point was that the axioms and good and evil, the God, those things are just all meaningless. Just follow your own nature. They're very similar with the Laozi and Taoism that I introduced to you in the first time. But anyway, he then gets stuck by his own thinkings in a dream. In that dream, a wicked dwarf jumped up into his shoulder and said, "Look, Zarathustra, as you can see, this world is in an infinite circle. Everything you do has happened once, no, infinitely many times, not just once, not just twice, but infinitely many times, forward and backwards, because time is a circle and space is also a circle." Zarathustra tries to counter-argue that dwarf's argument that everything is in vain because it is already predetermined in some way. Because whatever you do, it is in some point of time already happened. And what you will do in a second later is also happened. And what you do in your lifetime is also happened. And everything in this world itself is in itself, forward and backwards, infinitely looped. The reason why Nietzsche came up with this theory of infinite I don't know how they phrase it, infinite recursion, if I remember it correctly, is because at the time the thermodynamics was on its verge of epoch, so it was very flourishing. And there is a self-made note by Nietzsche that he studied very deeply the physics and natural philosophy of this time and space and energy. And he came up with this idea that since the total energy of the universe is stable, there should always be a finite amount of modes that our world can take, a finite amount of situations that our world can participate with that amount of energy. And since time is infinite in some way, everything we do should have happened once before time and afterwards, because time is infinite, regardless of how we live in this. And how he actually tries to solve this meaninglessness is quite uncertain, because even though Zarathustra tries to, in the book Zarathustra, refute this dwarf, he finds himself unable to fully refute him and find himself crying, weeping when he wakes up, and he goes into solitude again. And further, in his own notes, he does not make some sound arguments against it. But anyway, the book Zarathustra concludes by answering with this whole regression, infinite regression of universe and meaning of life, with a poem. I am not going to tell you the poem because it's long. Not very long, but hard to tell, yes. But anyway, the meaning was going on like this, that even though the world is forwards and backwards, always infinitely repeating, joy is eternal. So your life, your joy is what that matters. Even though it might be predetermined, what you do as you believe in, and what you do as you thought, and what you feel, the joys, the griefs, and everything else, is the meaning itself. That was his answer. The reason why I think this thing is related with our topic today is that when we think of simulation hypothesis, it has an underlying implication that everything we do, everything we think, can be explained in some very mechanistical way. If we delve deeper into our mechanisms of thoughts and behaviors, we're reaching into some core logics. And with that core logic, some simulators are being constructed. And in some way, there is no randomness because of that. As far as I know, there is no complete randomness of computer functions, even in this world, if this world is the top level or not. And probably everything we think about simulations is also in this line, that although simulation will elapse its own time and evolve through it, there is a certain mechanism controlling it, and everything is predetermined. I think that is why Siripon also came upon the thought of meaning of life. And this simulation hypothesis and all these movies matters so much because it is closely related with how we think of our life. If there is no such thing as randomness, if there is no such thing as a free will, everything I do is already happened, will happen. The only thing different with this Nietzsche's infinite regression and the simulation hypothesis would be that in the simulation hypothesis, there is someone with intention who is making this simulation already predetermined way to go on by. But in Nietzsche's thought, the law of nature itself is just is. It forbids every other possibility except that infinite repetition. In some way, Nietzsche's ideas might be more cruel if we are to accept his idea, that is. That came to my mind when you asked me about it.
Thank you. Actually, that was very impressive. I put you on the spot and you made up a 5-minute speech. Very good, yes. Okay, yes. Further questions or comments regarding the content of the talk? None? Okay.
Then I'll just add one more comment about the contents. Yes.
Yes.
I was very impressed in some way because I never searched about these kinds of topics and I never knew these arguments are happening. I am pretty much more interested in classical thoughts, and so Siripon's presentation about very recent, the 2003 paper, and its kind of noble argument that nobody would have thought of it unless you are a 21st century computer scientist, was very refreshing to me.
Thank you. Yes.
Thank you.
We have moved on to the evaluation part. So Gang-Jo Kyun has already given some feedback, and I would like to ask other participants also to provide some feedback, positive or negative, and also maybe some suggestions for possible improvement. Yes.
It was filled with like readable examples, which made the whole presentation like you can conceive that the concepts. It was not just concepts, but you can feel the concepts, and it was also linked to the content we had to watch. So still another step of relatability.
Maybe I add just something to that. I also liked your structure. And as Arno already has said, I also liked how you kind of related the topics to the movies, which we addressed. But especially I also liked the questions you posed and kind of how you, like these thought experiments you kind of introduce about really thinking about this whole simulation thing. It really leaves some questions as I still have to think about.
Thank you. Yes.
Yeah, but I really feel like I would have like discussion break at many parts also. Yeah, because I have left many open-ended questions. So, and I don't even have answer for some of those questions myself. So yeah, I would also love to hear about you guys' thought about the thing that I have talked about. And also, I think there's some flaw in my English. I would say it's pretty obvious that I've stuttered many times, I think. No?
No?
No, I think I know my level of English. Okay, so yeah. Thank you.
So what really impressed me is that many of the things you presented were actually far beyond the state of the literature. I had briefly looked into the literature of simulation hypothesis myself, but you, on top of presenting that state of the literature, you challenged the state yourself and you raised questions that I had not seen anywhere in the literature before.